So 8.5 is just a continuation of what we were doing yesterday. So again, we're just now doing the 4-step process of these sample mean problems. So we're doing the state, plan, do, and conclude on sample means. So let's take a look at this question here. It says the principal at a large high school claims that students spend at least 10 hours per week doing homework on average. Okay. To investigate this claim, an AP Stats class selected a random sample of 250 students from their school and asked them how long they spent doing homework during the last week. The sample mean was 10.2 hours, and the sample standard deviation was 4.2 hours. Construct and interpret a 95% confidence interval for the mean time that students at the school spent doing homework in the last week. Based on your interval, what can you conclude about the principal's claim? So at the end, we'll even talk about this interval and say, hey, is the principal okay saying this? Okay. All right, so we want to go through our 4 steps. The first one is the state. So we want to state what we're trying to find. We want to find now I'm going to go up here and look at the percentage. So a 95% confidence interval for the population mean number of hours spent doing homework at this principal's high school. Sorry, I forgot to mention one thing. So it should say mean number of hours, spent doing homework by students at this principal's high school. Because it's always good to mention who's actually doing the homework. Can't leave out the students, can we?
That's true.
That would be bad. Don't leave home without it. Alright, so we have our state, now we do our plan. So we want to know what type of interval we're doing and go through all the conditions. So we will construct a 1 sample T interval for a population mean, or for mu. Alright, so our first condition is it random? Okay. Well, how many students did the principal survey? So we have a random sample of 250 students. A simple random sample of 250 students was taken. So I'm going to do a little check and write yes. Second one is it normal? So, is our population normal? No. So, I'm just going to start with that. Our population distribution is not normal. However, what's going to help us out here? What's our sample size? 250. What is that bigger than? 30. And if it's bigger than 30, what allows us to say our sampling distribution is approximately normal? Well, I think I heard it. Central limit theorem, CLT. So, our population distribution is not now normal. However, since n equals 250, which is greater than or equal to 30, according to the central limit theorem, CLT, our sampling distribution is approximately normal. Independent. So, is the population greater than or equal to 10 times our sample? You got it. So is the population greater than 10 times 250, or is our population greater than or equal to 2,500 students? That's a big school. Okay? So we're going to assume that this is going to be the case. We're going to assume that maybe we're at Eden Prairie High School, or we're at Wayzata. Is Minnetonka up to 2,500? I think they're pretty close. Okay? I know we're a little bit smaller. Okay? So we will assume there are at least 2,500 students at this high school.
How many students do we have here?
About somewhere between 1,700 and 1,800, I believe. But we are 10 through 12, so if we were 9 through 12, I think we'd be a little bit closer. We'd still probably be around 2,300, I guess. EP and Wayzata are like in the 3,000s. Alright, so are all of our conditions met? Alright, so now it's time to actually construct the interval. So we're now doing the do. So x bar plus or minus t star times the standard deviation, whoops, wrong symbol, standard deviation of the sample over the square root of n. So what was our sample mean in this problem? What was the average hours from the 250 students? 10.2 plus or minus. Now I gotta do T star. Okay, so to do T star, I'm doing a 95% confidence interval. My degrees of freedom, 250 minus 1, which is 249. So when I look at my table, so if I go down here to my table, 95 degree or 95% confidence interval, I don't have the number 249. It's between 100 and 1,000. So I'm going to use my lower value 100 and I get 1.984. Let's scroll back here. So my T star is 1.984. This one's nice because they give me the standard deviation, I think was what, 4.2? Square root is 250. So 10.2 plus or minus. So I'm going to do a little quick calculation. Excuse me, get a little hiccup here. 1.984 times the 4.2. Then we're going to divide it by the square root of 250. Oops, I don't need that little parenthesis. So I'm just going to round it 2 decimal places, 0.53. So if I add and subtract 0.53, so if I go 10.2 minus 0.53, my lower bound is 9.67. If I add it, my upper bound is 10.73. So I have my interval. So my conclusion here is we are 95% confident that the interval from 9.67 to 10.73 captures the population mean. I'll move this up a little bit to make it a little easier for me to write. Number of hours studied weekly by students at this principal's high school. So, there was one last little part to this question, and that is, can the principal claim the mean is greater than 10 hours? Well, is it possible in our interval, or let me rephrase it this way. In our interval, are all possibilities greater than 10? No. We could have an interval, or we could have a mean that's less than 10. So, what could we say about the principal's claim? Okay. Can the principal claim this? No. It's possible the mean is less than 10 hours since our interval has values less than 10 in it. Okay. We would feel confident in the principal's claim if this interval of all of these values were greater than 10. But we could say with at least 95% confidence that, the interval is going to be somewhere in between here, which has values that are less than 10. All right. Excellent. I'll stop right